So how are you guys doing? Yeah. Are you doing good? Doing well? All right. So welcome back to the class. Again, so the first lecture we recorded, it was not, the video was recorded, but no voice. So again, I don't think it's going to be useful to you. I'm going to share it with you, but I think starting from this time, having this nice microphone here, I hope we tested it and it works, so hopefully it's going to work. It is actually my first time doing this kind of recording, and I'm doing it this year because a lot of people thought it's useful, and this is why it's taking a little time, like trial and error and stuff, okay? So apologize again. So last time have we talked about any assignments? No, we didn't talk about any assignments. We talked a little bit about the projects, and the first task in the project I asked you to do is very simple, which is form the groups. How many of you are still not part of a group till now? All right. So how many of you are groups of 2? 3? 4? Okay, that's good. Yeah. So people with groups of 3, nobody with groups of 2, I've noticed anyone. Just one. Do you want to join them? Yeah. I'm sorry I'm doing it on the spot because I want to make sure, because the deadline for forming the groups is Sunday. And what you're going to do is basically, after you form the group, and again you have 3 to 4 members, no more than that. Okay, no 5s. Anybody here is like a group of 5? No 5s. Okay, the maximum is 4. And then once you do that, you can use the discussion board. We already settled on the groups now, so but I mean there is one item in the discussion forum called group formation. So this was supposed to be used by some of you to ask that you want to join a group if you have a group up, or you want people to join your own group. But I don't think we need it now because we almost have all groups here. And the deadline is this Sunday. And it's a very simple task you need to do. You just go to Blackboard, just one of you, create the group, and add the people. Okay. There is a function called creating a group in Blackboard. And it's very simple. I mean, it's one of the, on the left pane, right, on the screen, on the website, you will find how to create a group. It's very simple, very straightforward, nothing complicated about it, right? So what you need to do, go there, just one of you, the team lead, pick a team lead, by the way, if you don't mind. And this person will add the ID or like add people to that group. So by the end, on Sunday, I want to see all the groups. It will ask you to assign a name to your group. You can use any name, right? You have yeah, right? Yeah, we had a lot of funny names in the past, and it's okay, right? Just please be appropriate, right? Like rating PG or less, okay? No, nothing about that, okay? Please. So yeah, that's for the group formation, and this is the very first task you need to have to do in the class. Very simple, right? After we do that, next week we're going to discuss what you need to do in the project. I'm going to give you just a quick overview now. So in the project, what you need to do is basically we have an application, and the application is that we have a data set, and the data set we have is called New York City Taxi data set. So this data set was released by the New York City or the limousine and taxi company, and it has around well above 1 billion taxi trips. And the taxi trips are basically the pickup location, the attributes for each trip, pickup location, drop-off location, and pickup time, drop-off time, the fare amount, the tip, all these kind of information, all this kind of information is actually stored in each trip. And you have, again, well above 1 billion trip between 2009 and 2015, the year 2009 and 2015. And basically in the project, we will be asking you to implement some kind of very simple data preparation, like for analysis and data analytics tasks on the data. Very simple. Like we're going to ask you, for example, aggregate the data, or write a function that aggregates the data, or write a function that aggregates based on the region, or the taxi pickup zone, or anything like this. So the detailed description of each task will be given to you in a written document, and also I will explain it in class when the time comes, right? And to do it, you'll be asked to use Spark SQL. We have been negotiating with like some cloud service providers so that each group will have access to a cluster. And this cluster, we will be posting the requirements, and again, so that everybody's working on the same platform, right? And the grading will be done also in the same kind of cluster setting that you guys are working on. So basically, we're going to set up the cluster for you and give you the access to the cluster, and the group will have access to, each group will have access to their own virtual environment. And also the instructors, like include myself and the TA, will also have access to your cluster so that we see what you guys do here. And basically, you're going to be posting or submitting your code on that virtual clusters that you have access to, right? So we are actually in the process, we've been in the process of negotiating how we can do that. We're coming to an agreement now, and this will be provided to you soon, well before you start the project. But starting the project, this is just for submitting your code and maybe test it on a large cluster. Once we start the project, you can still do all the programming and the learning and everything offline on your own, using your own laptops, your own computer, whatever it is, the existing labs that we have, install that. Because I want you also to go through the, I don't want to call it, I want you to go through the pain of learning how to set up Spark or Hadoop cluster and all these kind of things. It's a learning curve, and it's good to go through that, because we're going to give you something ready. I don't want you to be always having something ready to you. I want you to go through that. So it will be this kind of cluster setting. It will be well before the first phase of the implementation. Okay, give it to you so that you can experiment with it. So this is basically the idea behind the project. And in the project, we have multiple phases, 4 phases, beside the group formation phase, which is basically called phase 0. So the first phase is basically we have a system that does geospatial analysis. It's a ready system, and you guys can use it, download it, and use it. We're going to ask you to use that system to do some tasks, right? And then we have 2 implementation phases where you need to implement the same functionality that you witnessed in that system, but with also with Spark, but with Spark SQL. Okay, so it's the same environment, the same cluster computing system, but taking a different programming paradigm, right? But you're going to implement the same functions. So you go through 2 main phases for the implementation. And the last phase, which is phase 4, will be a project report. The project report, you're going to, again, describe how you implemented this, what is the system architecture, what kind of functions, what kind of algorithms you use. And also you're going to explain, most importantly, performance metrics on the cluster when you ran the jobs, when you ran the analysis on the New York City taxi data, what happened? Like, how much time it took to run a specific analysis task, the network utilization among the cluster nodes, the CPU utilization, the memory utilization, a lot of system tuning parameters you guys will be asked to report, okay, and explain. So it will be, by the end of the report, will be like a paper that explain your experience. And of course, you'll be delivering code as well through the phases of the implementation. And in phase 4 also, it's part of it is a report. Another part of it is basically like a poster presentation. So you will come to class, it's probably the last day of class. And in the last day of class, you're gonna bring a poster with you in the same room here. And you will showcase your project somehow. And everybody will look at it in the classroom, and including myself, of course. I'm gonna be, and this is also part of the evaluation of phase 4. Every phase has a percentage of the grade. Everything is in the syllabus. We already discussed it, I guess, the first time, right? The split of it. But again, it's also in the syllabus. Some people ask me questions about the syllabus. I mean, the syllabus is available online. Just making sure that everybody has access to it. Also, the office hours is right before class, right? So if you need anything, I have 2 hours a week, 1 hour before class on Monday, another hour before the class on Wednesday. Sounds good? And the TA also has office hours, right? Johan, you have office hours, right? He's going to be sending you, the office hours are not in the syllabus, his office hours. He's going to be sending you on Blackboard his office hours, okay? Where you can, when you can talk to him. So far, the teaching team is only Johan and myself. We may have a grader also at some point in time if needed, because again, the large scale class may require this. But so far, we don't have another personnel on the teaching team, right? Just clarifying things. You guys have any questions? I realized last time I kept talking, and yes, please.
We have a class just before this class on Mondays and Wednesdays.
All right.
So, is there anything can be done?
When you say we, you say you or everyone?
A lot of people.
A lot of people. All right. Like how many of you has a class right before this class? Okay. So it's like, yeah, I don't know. Because, so are you talking about the office hours? You want to shift it? It's a little tough because if I optimize it for you, the other people also take in classes on other times. It's not everyone in the class. If it's everyone in the class, I would take the decision easily. It's fine. How many of you have classes on just an hour before that, which is from 2:25 to 3:25, or in this time? Like how many? 2:25 to 3:25. Raise your hand. Yeah. It's you again. You're taking classes in, yeah. You want to finish in just 1 month, the whole degree, get your master's right away, right? So, okay. So who has a class from 1:25 to 2:25? Nobody. Oh, you guys. All right. Can we, like, since you are the minority, okay, can we take that slot? I mean, if you don't mind, and make it the office hours? Do you have a class also right before this class?
No.
No? All right. See, he's gonna feel bad now, right? Yeah.
It's okay. I can go to the TA.
Can you go to the TA office hours? Anyway, I mean, if you have, here's the thing. There are so many channels for communication with me. The worst way to communicate with me is sending me an email, right? I'm not saying that you shouldn't send an email. You should send an email whenever you feel like it. But why I say it's the worst way, because I receive, and I'm not kidding you, I receive 250 emails on average a day. 150 of these I have to respond to, right? So this means that till I get to you, and maybe I, like the human error, I may miss it, right? Which happens, right? Not only with you guys, with other people as well. And put me in trouble, but it's just too much. So you can still send me an email. I'll try to respond within 48 hours if possible, okay? But there are other channels, which is the Blackboard, right? The discussion forum. You can communicate with me or the teaching team in general on Blackboard. It's a more efficient way to communicate with us because it's centralized. Everybody can look at other people's questions, and it makes it easy not to replicate questions. And please take a look at other people's questions, okay? I know it's an effort, right? It's like a minute, you scroll down or something like this, but please do that effort. Yeah. Another way is you can send me you can use the hashtag, right? And using the hashtag, don't share personal information, right? This is public. I don't want you to do that. So if something very personal, come to my office, right? And we will talk it. But if something general, please share it. And what I do is that I'll collect all of this, prepare a video, just a quick clip to answer all the questions. Or if there is time in class, I'll answer it in class. I'll bring it all in here. Let's answer that. And don't be, it's okay. I mean, whatever kind of question on your head, I consider it smart, right? Don't worry about judging other people or something. Because some people prefer the email. But I'm telling you, it's not the best way to communicate with me, right? But do it if it's something personal. Don't share personal information in the effort, right? Other questions before we move on? Please.
Cluster requirements. So what are the cluster specifications?
Yeah, we will tell you that. All of this. Don't worry about it. Yeah. We will come to that and we'll give you all the details and everything will be fine. But we're gonna the general information. We're working with Apache Spark, and my recommendation to you is to start getting your hands-on experience, getting your hand dirty with Apache Spark. Apache Spark is an online, it's open source, free system that you can download. And there is a lot of tutorials online. So download the tutorials and run it and do everything, okay? I'm okay with it, but I mean, it's just like distract me a little bit, okay? Otherwise, I'll be fine, right? Okay, so, see, you distracted me, man. Come on. Yeah. All right. Yes, Apache Spark. Start downloading Apache Spark. Get hands-on experience with it. Get your hand dirty. Like run the examples, right? So that you understand the system. So that when it comes to the real thing you need to do, it's not gonna be like a huge cultural shock to you, right? Especially if you haven't had any experience with Hadoop or Spark or anything like that before. Sounds good? All right, let's move on because we have a lot of things to cover today. Last time we stopped at transparency. So what we mentioned about transparency is basically you have a distributed system, and the distributed system is you have multiple components in the system, but from a user perspective, from an application developer perspective, it is one single system. What does that mean? Okay, from a database perspective again. Let's take a look at this classic example of distributed system. So you have a database, and the database is basically, it's a company database, and the company has a table that has all the projects, another table that has all the employees working in the company and information about them, and the assignments, which is which employees assigned to which project. That's another table. It's a very simple database. But let's assume that the company is using a distributed database. That means that the data itself is distributed. You have some server is in New York, one in Montreal, and different cities across the world. And in New York, you store all the Boston projects. Okay. New York employees, New York projects, New York assignments. And in Boston, you have the Boston projects employees assignments. As you can see, there are some data that is replicated across the servers. We will come to why sometimes we need to do replication, but let's just forget about that now. Montreal, so the idea is basically the data is cut, is partitioned or fragmented, and distributed across the servers in different cities based on because the servers in New York, I'm storing all the New York information in New York. It's a good way to do partitioning sometimes. The same way you do, for example, in Facebook. If you live here in Phoenix, your information, Facebook information will be stored in Phoenix, okay? So that it's faster across the map. So that's a very simple way to do partitioning or fragmented data. All right, and you have a network. All of this is across the network. What happens if I want to have a query that selects all the projects that this company is working on? Given this kind of structure, how can I do it? Very simple. So every single city has part of the data. So what you need to do is basically go to New York, get all the projects, the part of the table that has all the projects, Montreal, all of them, till you get all the projects, put them together, and present it. It's a very simple select query, select from projects. Very simple. But you, as an application developer, if you have all the information about the partitioning, fragmentation, replication, you have to do a lot of effort to collect this data. You have to know where each piece of data is stored across the network. So if you have to know all of that in order to run this query, this system is not transparent. Very simple. So if you have more complex query like this, again, a query that does like a join between employees, all the tables that we have, and does some kind of where plus. Forget about the logic behind the query. The idea is that I need to go get all this information from all the tables and do these kind of filtering on the data. This query to run, if you don't have a transparent system, as an application developer, you have to split it into multiple queries based on where the data is located and submit this subquery to each part, each city, and then you get the result, do the combination, all this kind of join and stuff, right? But since the system is transparent, it has a transparency property, you can just run this query and it runs as if the data is in one location. So we call this fragmentation transparency. Okay. Also, the data is replicated sometimes. The application developer doesn't need to know anything about that as well. So we call this replication transparency. So all of this will actually be very beneficial for people like if you are an application developer, but if you also are a data scientist, right, running analysis, like group by average, right, this kind of statistical SQL analysis queries on the data, you don't need to do all of that because all what you care about is your own application, the statistics you want to collect. The system can do all the dirty work down there. You're totally isolated from it. And if you experienced almost, like if you work even with modern big data systems like Hadoop or Spark, you as a developer of the system, you don't see how the cluster is distributed, where the nodes are in different areas. You don't see that. You run a program, and whatever it runs, right? You don't know what's going on, right? Where the data is coming from. Key feature in distributed systems is transparency. Okay, so now we've seen that in a distributed database system, the data is distributed across the cluster. You have multiple servers, probably servers in different cities. But the first question, how can I get from just one database that is centralized to a fragmented database, distributed database? you need to do some kind of data fragmentation, okay, or partitioning. So, what is the easiest way to do partitioning or fragmentation? Let's stick with fragmentation. So, what is the easiest way from your perspective? If you have a table, let's take again the example of the table is the projects table that we just discussed, or the employees table. What is the easiest way? By row, right? So every set of rows, it's a fragment. Simple as that. So you have this project, these are the set of projects. You put 2 of them in one fragment, the other 3 in the different fragments. This is called horizontal fragmentation. Another way, per column, right? Which we call vertical fragmentation. So you have 4 columns. You partition them into 2 set of columns here. And you have 1 shared column between both of them. Why is that?
Primary key. It's a primary key.
And what's the importance of having the primary key in both of them?
It's a unique identifier
For each row. Otherwise, you cannot reconstruct the original. If you don't have this duplicated, you cannot reconstruct that. We're going to come into all these. There is a theory behind that. I'm going to come to that just in a few slides. So, what is a good fragmentation? That is the question. So, yes, let's do horizontal fragmentation, for instance. Is it good or bad? Like, let's assume you have a table, and the table has an attribute salary. It's an employee salary. And this is one way to do the fragmentation. F1 is one fragment, F2 is another fragment, and this is the relational algebra selection operator. So you select all the employees with salary less than 10, and the other one has all the employees with salary larger than 20, all the rows. Is this a good fragmentation or not? Why not?
If you look for a particular project, we won't find like all the people working in the project because they're partitioned based on the salaries.
Yeah, no, let's assume I decide to partition on salaries, okay? And I'm doing this, this is an employee table now, okay? So is this a good fragmentation or not? Salary what?
Having between 10 to 20 won't be visible in any of the fragmentation.
10 and 20 is all lost, right? So it's not a good fragmentation, obviously. Makes sense. So we lost some information. So this means you cannot reconstruct the original table or original relation. Some tuples lost. So very obvious. Okay, this is a good fragmentation or no? Did we lose any tuples here? No. So why is bad then? Duplicates, right? So we have a lot of duplicates between these fragments. So this means both F3 and F4 are not disjoint. Okay, please.
Wouldn't having duplicates be a good thing for redundancy? Wouldn't having duplicates be a good thing for redundancy?
We'll come to that. It is actually true. Sometimes you need to replicate data, but not that way. Okay? So there are tuples are duplicated. So when it comes to the question of replication, so as the gentleman back there mentioned, so it is actually preferred to deal with replication as a separate problem. What does it mean? Once you do the fragmentation, you can decide to replicate the fragment or not. But the fragmentation is better be disjoint, it's better be complete, it's better be easier to reconstruct the original table, original relation from the fragments. So all what we discussed now, very simple properties, but this is the theoretical definition of these properties. The first property of a fragmentation, of a desired fragmentation, is called completeness. And The completeness means if you have multiple fragments, fragment one relation into multiple fragments, R1 to Rn. This fragmentation is complete only if this condition happens, which is if and only if each data item in R can also be found in any of the fragments. So this means the fragmentation is complete. So data item in this case, we're talking about rows or tuples in the fragment. If one tuple does not belong to any of the fragments, this means the fragmentation is not complete. You lost the completeness property. Simple. And we had an example about that already. Reconstruction. Reconstruction means, again, you have a fragmentation, R1 to Rn. The reconstruction rules means that there must be a relational operator or a set of operators that can be used to reconstruct, if applied to all the fragments, can be used to reconstruct the original relation, R. So that's a reconstruction rule. If there is no such relational algebra expression that allows you to do that, this means this fragmentation does not have the reconstruction property. Disjointness means, again, if you have R1 to Rn fragments, it satisfies this property if and only if each data item belongs to only one fragment. Right? Make sense? All right. So let's do this simple activity. Here's what I want you to do. Each one of you, with a group of people around them, I want you to look at this table, very simple table the project table, and I want you to give me an example of a fragmentation that does not satisfy completeness, does not satisfy reconstruction, and another example of a fragmentation that does not satisfy disjointness. Each group of people. So gather in a group of 5 or 6, right? People with your neighbors. And I want you to write this down in a very clear font, like writing, handwriting. 2 minutes, right? So please wrap up. 2 minutes. Do the same way. So write it in relational algebra the same way. All right. So I need 4 volunteers from each group. Sorry, 4 volunteers from any of the groups, right? So 4 people, okay? But they have to be from different groups. And so if you volunteer, there are extra points, right? Oh, you're ready, man. Okay, so it's first come, first serve then. Please. Please, yeah, ready. No, come with the paper that has the fragmentation and this. No. He's first. He's first. He's first. So you, please. No, I mean, I'm sorry. I mean, he came first. Yeah, but next time. Yeah. All right. So here's what I want to do. So where's the 4th one? Where's that you? All right, please. Sorry. Come in. So what we are basically going to do is see my hand? Right. Do you have the paper that has everything? Yeah. Okay. So first off, here's how we're going to do this extra credit kind of thing. So whoever is going to participate is going to take the extra credit anyway, even if whatever there is no correct answer, right? So I'm cutting you a deal here, so don't worry about that. Okay. So you just have to provide your name to me, or if Johan is here, Johan, just give your name to Johan. If he's not here, just give me your name, right? And then we will record this into the system. All right, but the extra credit, like one time, doesn't mean that you take it's just incremental, but it will add up at the end. So here's what we're gonna do. How many of you have seen America's Got Talent before? Too bad. Yeah. All right, so you know what I'm talking about then. So here's what happened. I'm not sure if it's America's Got Talent that has that or no, but you know the buzzing system?
Yeah, golden buzzer.
What is that?
Golden buzzer.
Yeah, whatever you call it, man. Yeah. It is, yeah, what he just mentioned, yeah. So the buzzing system is that where you, what's your name?
Dipankit.
Dipankit is gonna present the solution of his group. And what we're gonna do is basically, if he has something wrong, we're gonna buzz him. All right? how we're gonna buzz him? That's a B, right? Yeah. You can do that. This is fine. Yeah. You can do bah, something like this. Yeah. Yes. So buzz him in any way, right? Anyone can buzz anyone at any time. So, the Punkit, please. You just projected on the. No. Yes. Sorry. So which one is which?
Yeah. So
Just wait a minute.
So we're gonna do horizontal.
Guys, just quick. Just buzz, okay? The only sound you're allowed to do is bah, right? It's fine. But not all the time. Yeah, it's fine.
So
right.
we're gonna do horizontal fragmentation, and we have chosen.
Wait a minute, okay? Listen to the Punkit.
So we have done horizontal fragmentation where we focus on like each row, and we have chosen budget as the column where we're gonna perform some criteria. So first one was does not satisfy completeness. So our query was if budget is less than or equals 2 million or budget is greater than 3 million. So if we take that.
How is this happening?
No, it's like distal zoom activated. What does that mean?
Did somebody hack into the system?
I will touch it, I promise.
I know. I believe you, don't worry. All right. So what do you think of the horizontal fragmentation that he provided here? So what do you guys think? Is it complete or not?
It's 200,000. Less than 2 million. However, the first fragment will have everything.
I mean, it's basically like $200,000.
Yeah.
So it was 200,000, right?
Yeah.
So less than 2 million covers everything. Yeah, larger than 2 millions doesn't cover anything. So okay, before the dot, would you buzz it or no? Exactly. Okay. So number 2, what is that?
Yeah. So if we take the first partition into
Don't face
consideration.
your solution. Okay. Yeah.
Yeah. So if we consider the first fragmentation for the horizontal, and if we try to like segregate all the rows, we're gonna miss the third one, which has entry of $225,000, 225,000, 250, I believe, and for what is it?
All right.
I mean,
So what do you guys think of that? He said the opposite of 1. Same issue?
yes.
It can be the same as 1.
Yeah. I mean that's another possibility.
So it does not achieve disjointness. It's actually why?
Does not achieve.
It is actually disjointed, right? It is disjointed. Okay.
No. I mean for the reconstruction. For disjointness.
For the reconstruction, yes. Yeah.
Yeah.
Makes sense.
Yeah, and for the disjointness, I had like like if a budget is less than or equals 0.25 million and budget is greater than or equals 0.25 million. So it's basically your the.
So what do you guys think of the
boundary
third
condition
one?
is the same. Yeah. So just like the boundary condition is the same.
Is the same, and in this
Yeah.
case, it's not disjoint.
Yeah. In this case, it's not disjoint.
You guys disagree or agree? Okay. Let's thank the Punkit, please.
Thank you.
Thank you. Tejo, right?
Yeah. Well, my solution is pretty much the same.
Also 3 million?
a budget is less than 150,000.
Okay.
So if you do that, it covers everything but the 250 and 310 and 500. But for the greater than 310, it covers only the 310 and 500.
Yes.
So we missed the 250,000.
Does it make sense? All right.
And for the second one, it's the same solution as the first. If we just do a union, we miss 250,000. So reconstruction is not possible. And for the third, it's the opposite of the first one. We see 250,000 twice in both the fragments.
What do you guys think? Anyone who wants to buzz in? Taejeon. Let's thank Taejeon. Utah? Yeah. Utah.
It's kind of a little dirty. But this is our first answer. That is, we divide the.
So wait. Right?
That is, we divide the budget for the first group that is less than 15,000, and the other group that is greater than 30,000.
30,000.
Yeah.
So in this case, it's
we miss the P3 project
So-
3. Yeah.
so it's not complete.
Yeah.
Yeah. Who agrees with him? I agree. Yeah. Okay.
Thank you.
So yeah. Oh wow. Thank you. He says thank you. Right. Yeah.
And this is for the answer of the second problem, so that we simply divide the table horizontal, vertically, so that it cannot be reconstructed in the future because we miss the project number in the second part here. This is only the budget and the location.
So here, what you did to get an example, of not being reconstructed or to not satisfy the reconstruction is basically did like a vertical split with a vertical fragmentation, and you didn't include the key in both of them, right?
I include the key in the first one, but not in the second one.
Not in the second one, and in this case, it's never reconstructed.
Yeah.
Makes sense, but is it complete? It is complete, right? Because all the data is there that we need, but it's cannot be reconstructed. And that's actually the very first example we had that does not satisfy reconstruction, but can satisfy completeness, right?
And for the not satisfy the disjoint needs, here is the answer. We divide the tables in two groups, and the first one is less than 30,000. So that P1, P2, and P3 is all there. And then the second one is greater than 20,000. So that also P3 is all there.
Do you guys agree? Yes. Awesome. Let's thank Utah. Yes.
Thank you.
So for the people that are done, can you go to Yuhan and just give him your name, right? Please. Yeah. So what's your name?
Say so.
Say so?
Yeah.
Okay, say so. Last but not least.
Okay. So for the first fragment, the budget is less than 150,000.
I know it's annoying, right? Yeah.
And for the second fragment, budget is greater than 300,000.
Okay, this one does not satisfy completeness. You guys agree?
Yes.
And does not satisfy reconstruction.
Yes.
So right.
And for the disjoint, the third element, which has the value 250,000, appears in both the fragments. So it does not satisfy disjoint.
It does not satisfy disjointness. Awesome. Let's thank him again. See, activity. Can you please, everyone, like just give your name to Yuhan? But can you see it? Participating in the class activities is easy, right? So and you can get points, extra points also. All right. So what did I want to say here? So what I want to say. From this activity is that two main things. You can achieve completeness without achieving the two others, right? And things can be complete, but at the same time, it may not be reconstructed. A lot of people get confused between these two, but there is overlap, but they're actually separate somehow. So reconstruction has overlap with completeness and disjointness, but not total. It's not the same definition, right? And we've seen this example of something that is complete. All the data items are there, but cannot be reconstructed. You have a question here.
You said that you cannot achieve completeness without achieving reconstruction or disjointedness. If we do not have disjointed, that means we have duplicate records. But even if it's duplicate, it's complete, right?
Yes,
So you are achieving completeness without achieving disjointedness.
yes, I'm saying that's okay.
That's
Yeah.
what I'm asking.
Yes, what's the problem that you can't? I didn't say the opposite. I said there is overlap. Yeah, sorry about that. So let me clarify. There is overlap between, that's what I said. There's overlap between disjointness and completeness on one side, and disjointness and, reconstruction and completeness on one side, reconstruction and disjointness on the other side. There's overlap. But that doesn't mean that they're both, you can, like, any of them is equivalent to the other. So, and that does not negate whatever you said. You're right, okay. But thanks for asking the question. That clarified things. Yeah. Other questions? Please.
So just his example says that we separate the fragment with vertical.
Who does example?
Yeah,
right?
but if it's vertical without the primary key, how can you get all the data?
You cannot. This is why it cannot be reconstructed.
So that.
But all the pieces are there.
Complete. It's not complete.
No, it is complete.
Because
all the pieces are there.
But you cannot retrieve data. Exactly.
You cannot reconstruct it. Yeah, this is true. But every single piece of data, if you just randomly put them in a bucket, everything, it's all there, right?
So that's
but you cannot reconstruct the original thing.
So complete, that means everything is there.
Everything is there. It's complete.
But seems the definition of complete not the same.
No, it is.
Kind of.
The definition of completeness is if you have multiple fragments, okay? Any data item must appear in one of the fragments, okay? If it does not appear in any of the fragments, it's not complete. So in his example, every single data item appeared, right? He has everything. But try to reconstruct it, no way you can reconstruct it, right? So the theoretical definition is valid. Let's move on because we need to cover other stuff. Yeah. Allocation alternatives. So once you do the fragmentation, vertical, horizontal, you make sure it's complete, whatever it is, you need to allocate kind of that fragments. So there is non-replicated allocation, and this means that you fragment the data, and every fragment exists on only one side. It's non-replicated. And then there is replicated, and replicated, of course, there is a huge spectrum of replication. Either fully replicated that you have every fragment is fully replicated across all sites, or you have partial replication. So each fragment is selectively allocated to a couple of fragments. So this is basically the idea of replication. And in practice, systems these days, we have partial replication. Either relational database system, if you have a distributed relational database system, or even like a big data system, big data processing system like Hadoop, for instance. When you have data is replicated a bunch of times on a couple of machines in the cluster, each fragment of the data. Make sense? So these are the different fragments. And the idea here is that if you have the read-update workload that you have, if it's, this is larger, not less than 1. If it's larger than 1, replication is advantageous. Otherwise, replication may cause problems. So again, this is the degree of fragmentation. So degree of fragmentation means you either fragment, you have every tuple as a single fragment, or you have the whole relation as a single fragment. There are all possible scenarios that you can go through. So we went back, these are the basic definitions: completeness, reconstruction, and disjointness. We just discussed that. The question is, how do we get completeness and disjointness? If I want my fragments, I want to have different fragments of the same relation, and I want to make sure that I achieve disjointness and completeness. Very simple way is just take the relation or the table that you have all the data in it, and manually check if it achieves completeness or disjointness. Easy, right? It's not. Okay. So it's not easy, because if you have like a huge table, you cannot do that, and there are like a plethora of possible combinations you can do of the fragmentation. But you can automate the process a little bit. So how can you do this? So the idea is that you have in one table, you usually, the workload coming to you, like queries coming, like asking about this table, like for example, if you have a lot of queries asking about the salary, a lot of queries asking about the names of the employees, whatever, simple attributes that the query is asking for. So this workload can give you an idea of how to start to fragment your table or relation. So in each query, there are predicates. If you've taken relational algebra before, the predicate is basically, in the query when you say select from where there is a condition or a constraint, this is called a predicate. It's called a simple predicate in predicate logic. And it's put usually in a relational algebra in a conjunctive form. So this simple predicate, if you look at it in practice, is the predicate that has salary equal a value. That's a simple predicate. So if you have a table or a relation that has a set of attributes, okay? So for each relation, you can define a set of simple predicates. And an example based on these attributes that we have, the domain of the attributes. So an example of that, you have the project name equal maintenance, or the budget is less than or equal 200,000. These are all simple predicates. And then there is something called the min-term predicates. So the min-term predicates are a set of, they can be defined given a set of simple predicates. It's kind of a conjunction over a subset of these simple predicates defined on the relation. What is an example? I don't want to complicate with the theory, but the example is something like that. So these are min-term predicates. Min-term predicate 1, project name equal maintenance, that's simple predicate, and budget less than 200,000. So as again, it's a conjunction between two simple predicates. Or the negation of the same simple predicates. You can also end it with the other one. And you can do all these kind of combination between all the simple predicates that you have. And enumerate all of them. Once you enumerate all of them, you can decide whether each min-term predicate is actually good or not, valid or not, given the properties that we're looking for. Let's take a complex example here. So you have again the relation, employee relation, has employee ID, name, location, salary, and another attribute called A. Okay, it's an integer value, and the location has two main values, either SA or SP. These are the two possible values for the location attribute, right? And the salary is just a continuous dollar amount. Min-term predicates. So you can define min-term predicates like that. So the attribute A is less than 10, attribute A larger than 5, location equal SA, and location equal SB. So you can do all the combination of the simple predicates to get different midterm predicates like that. So this can be automated, like the algorithm can automate that. But do you see any problems here in any of these midterm predicates?
Duplicates.
Where?
Duplicates.
Like 1 or 2 or 3?
I can say in 3. The location not equal to SA. Both second and third.
Second and third. So location. What about? Let's start with the first one. Do you see any problem with the first one? Location can be both, right? So that is a problem. That's like a mathematically incorrect from a logic perspective. So location cannot be SA and SB at the same time. It's either that. It's either SA or SB. So there's a problem here with this midterm predicate. So the algorithm can figure this out. So what about number 2?
Yeah, same condition.
It's the same, right? So in location also. So what about A? The condition on A or the predicates on A, are they right? There is an overlap. It's not disjoint, right? What is a way to fix that? Algorithmically or mathematically? How to fix it? So this is basically A less than 10 and A larger than 5. So how can we fix that? Yeah, you can just put them together, right? Combine the two together. So there are, if you go on all of them, a lot of them has issues. Either some of the simple predicates don't match together, or some of them can be actually merged together to make sense. So the first one, it didn't make sense at all, right? Just because this condition will never happen. There will never be a row like this. So this midterm predicate is invalid. The same for 4, 5, and 8. For 3, this is not necessary. And also for 2, it's not necessary because it's the same, right? It's not necessary to do that. And the same here, you can actually combine both of them like this in one. And the same you can do here. So all of this can actually use the mathematical, the mathematics behind logic and relational algebra to do all of this automatically. You don't need to look manually into the midterm predicates yourself. And the algorithm can do that for you. But how can you decide the simple predicates in the beginning? Usually it's coming from the workload coming to the system. So you run the system, you have an initial fragmentation, you have a workload coming, workload being query workload, and the query comes with predicates in it. So you take those simple predicates and you use them in the simple predicates in this algorithm. And the algorithm can use, again, predicate logic and relational algebra to fix the issue. So again, I mean, that was not the end of it, that we have a lot of combinations here in total. And there are issues with all these combinations you can bring together. So you saved a lot of space that way, and your fragments are, after you do all of this, you have good fragments, like this. So these are the basic fragments you get after you do all these kind of midterm reduction. So this kind of technique that we see is called primary horizontal fragmentation. And there is an algorithm for it, right? That follow all the steps that we just mentioned. And you eventually come up with these fragments, okay? So I will end it here because apparently the class ended, yeah. And I'll see you on Monday. Yes. Oh, Monday is Labor Day. There is no class, unfortunately.